and present the world's best sixth-generation fighter that would outperform the U.S. F-35 and keep China's Air Force at bay. Japan has already demonstrated very advanced capabilities in many relevant fields of research and development, including world-leading composite material and radar technologies. The country was the first to deploy a fighter with an ASA radar, the F-2, and the first to deploy an air-to-air missile guided by such radars, something the United States and Russia both have yet to achieve. And recently, Japan unveiled the F-35. The FX is planned to be a generation ahead of the F-35 and a solid rival for Chinese and Russian stealth fighters. While the core design, including airframe and engine, has already been finalized right around the time that the F-2 jet is due to be phased out, $1 million. While the overall FX program is expected to cost Japan another $45 billion. Additionally, Japan signed a contract with Lockheed Martin valued at around $23 billion for purchasing around 200 F-35s. It remains to be seen if Japan's defense sector can juggle two costly procurements simultaneously. But there's still a few central questions like, for what does Japan need an expensive FX fighter fleet and additional 2 squadrons of imported F-35s for? And what characteristics will make the FX the best of all sixth-generation fighters? Let's start with the last. As we know, Japan has produced a number of American fighters under license domestically, notably including the F-4E Phantom, the F-15 Eagle, the F-16 Fighting Falcon, and heavily modified form as the Mitsubishi F-2 and F-35A Lightning II. All of these aircraft are currently in service in the country's Air Force, and all except the F-35 have significant modifications which distinguish them from the American originals. Despite its formidable technological base, Japan notably has not put in indigenous fighter design for air-to-air combat into production since World War II, meaning the upcoming sixth-generation jet will be its first. For decades, Japan has sought a high-end sixth-generation fighter with capabilities for air-to-air combat exceeding the F-35, Chinese J-20, Russian Su-27 fighters. The country initially planned to buy the American F-22 Raptor for such a role, but an export ban followed by termination of production in the first term of the Obama administration effectively ended hopes for a meaningful upgrade. Missing out on the F-22, Japan began to develop an indigenous fifth-generation plane, with several notable differences compared to the U.S. fighter, including challenging engine XF-91 and 3D vector thrusting that resembles more of Russia's Su-57. The project seems to be on its way up until 2016, when the X-2 Shinshin prototype from Mitsubishi Heavy Industries carried out its maiden flight. Since then, however, not much has been said about the program. Some say that Shinshin X-2 could be related to the FX program, mounted display, and a radar that can double as a microwave weapon to fry enemy missiles. It'll be designed to exchange sensor data with Japanese and U.S. forces and have a capacity for at least 6 internally stowed weapons, including air-to-ground and anti-ship missiles, though air-to-air will be its primary mission. Additional measures intended to make the FX stealthier include electromagnetic wave absorbers, metamaterial application, and using ionized gas or plasma stealth to reduce radar cross-section. To decrease weight, the FX will get heat shields and integrated bonded structure made of composite materials, enabling aircraft to fly out to substantial ranges to allow flexible basing from central Japanese islands. Each FX jet will be capable of controlling up to 3 loyal wingman-style drones using a shared basic design, weapons carrying missile mules. Both the drones could improve the FX's offensive capability while greatly reducing the manned jet's exposure to enemy attacks. However, Japan isn't going entirely solo on its domestic stealth fighter. Tokyo confirmed that manufacturers Lockheed Martin and Northrop Grumman would be its primary international partners. Japan said the U.S. companies were selected because it has considerable experience developing fifth-generation fighters, the F-22 and F-35, compared with the other 2 candidates, BAE Systems and Boeing. The former almost will involve consultation on the radar absorbent materials developed by Lockheed Martin and other techniques used by the firm to reduce the radar cross-section of its F-22 and F-35 fighters. Japan also hopes to pick the brains of Northrop Grumman, particularly regarding sensor and networked warfare technologies, which are prominent in Grumman's Super Hornet jets, E-2D Advanced Hawkeye airborne early warning and control planes, and the F-35's Distributed Aperture System multi-sensor. Mitsubishi Electric will focus on mission systems and electronic warfare capabilities, particularly self-defense jamming. Japan has also researched high-speed data link tech called Integrated Fire Control for fighters that could allow Japanese and possibly U.S. fighters to pull together their sensor and missile targeting capabilities, enhancing the accuracy of beyond visual range missiles. Meanwhile, IHI Corporation has been testing the jet's XF-91 low bypass turbofan engine since 2018. These incorporate exotic materials to reduce size and increase heat tolerance to 1800 degrees Celsius. The XF-91 produces up to 12 U.S. tons of thrust, or up to 16.5 tons with afterburners, slightly less than the F-119 engines on an F-22 Raptor. However, the XF-91s are slimmer and each generates 180 kilowatts of energy, cumulatively more than any U.S. fighter. Japan has also been testing thrust vectoring nozzles for the XF-91, which could allow extremely tight maneuvers. Besides, the U.S. F-22 and Russian Su-30 and Su-35 jets feature thrust vectoring, and China has been testing thrust vectoring engines on its J-10 and J-20 fighters. Electronics manufacturers Toshiba and the Fujitsu Group will take the lead in developing the FX's gallium nitrate ACER radar, which can also be powered up for use as a microwave weapon against incoming missiles. The radar will be supplemented by an infrared sensor and an electromagnetic sensor, an ESM. Subaru will develop FX landing systems. Though better known as an automobile manufacturer, Subaru's aerospace division builds wings and landing gear components for the Boeing 777 airliner. So Japanese FX will definitely be one of the most powerful sixth-generation fighter jets. But it's interesting that while building a new fighter, Japan is buying from Lockheed Martin 2 squadrons of F-35B stealth jump jets and F-35A. To be clear, Japan has lots of outlying bases on islands, which would be awfully exposed if China attacked. The F-35Bs will not only fly from the Japanese Navy's new light aircraft carriers, but they can also fly from small island airstrips, helping to extend Japan's air power across the East China Sea all the way to the edge of Taiwan's airspace. The single-engine F-35B features a novel propulsion system that combines a swiveling engine nozzle with a downward blasting lift fan. Together, this gear allows the 18-ton fighter to take off after a short takeoff run of fewer than 500 feet. That's why so many countries that operate small aircraft carriers lacking catapults are acquiring the F-35B for shipboard use. But the same short takeoff capability also is helpful on land. An F-35B, in theory, could operate from short runways on far-flung islands. The F-35Bs will fly from the Japan Maritime Self-Defense Force's 2 814-foot-long light carriers, the Zumo and Kaga. When not at sea, the jump jets could disperse across small airstrips in the Okinawa and Sakishima island groups. However, the F-35 is a complex, maintenance-intensive machine, and its island airfields would require substantial manpower and support equipment. So the new fighter jet will be awaited for such defense missions too. And that's all the time we have for today's video. Please give this video a like if you learned something new,